Today I am going to discuss some equation solving algorithms. So I have already discussed number of linear equation systems, but here we will discuss how to solve equations like a linear equations, quadratic equations, and so look here, we have to understand we have already understand how to write a matrices. So let's try. So SCI pi means science pi, scientific computing. So if I write here from ROM underscore feature UTURE underscore import division, right? So you write here from future underscore division. So we get the same behavior like a Python 2 and 3 and respect to the integer division. So we also include some new features if it is a given like something. And so what is the linear equations? Just linear equations means if I write here x a11, don't need to okay, don't worry, don't need to the import here because division, okay. So let's see here. So x1 a11 x1 plus a12 x2 and plus a1n xn will equal to b1. Similarly, in the second row, first column, a21 x1 plus a22 x2 plus a2 n xn and will equal to b2. So now we can write these equations and look like as a matrix form. So matrix form means a11 a12 till a1n. Similarly, a21 a22 and we can write a2n, and in the first column a m1 and in the last end of this rows and column a mn. And x, because variable contains like a x1 x2 till xn and will equal to b1 b2 till bn. So these are the way we can write this equation. But before that, so if you write here the matrix form and after that you try to understand how to write these variables like equations. So let's see, the square systems means if a rows and columns has been like equal, so this is called a square matrices. So if I write here like a simpy, so import a simpy. So let's see, the first I have already from import a simpy. I need to discuss here look like yeah. So need to the import here matplot and simpy is also here, okay. So this has been, these are the main libraries, so need to the import here, and after that import this one like a science pi SCI and pi we can write some symbolic code. So go first, you can start here need to the language. So in np.language, and I'll see here there's some graphical representations. So need to the import here something let's see the from sci pi import lina lg la. Okay, so it has been imported. So now the second, we need to the import from sci py import optimize and next import simpy. I have already imported, so let's try again. Import simpy right, and after that simpy dot init underscore printing and parenthesis input numpy as a np numpy as np and import matplotlib with plotlib dot pyplot as plt. So this library has been imported. So numpy, simpy and matplot library already we have introduced in the previous videos. Then after that, so first we get from the feature import division. So now let's try some different codes. So first we can define the simpy. We are creating the matrix object and A and B computing rank, conditions, numbers, norm of the matrix like the E. So if I write here capital A will equal to, actually I am creating like a one matrix as a simpy sympy dot matrix matrix, right, and now parenthesis, write a square brackets, and then we can write here 2, 3 and another 5, 4 right. And similarly I need to write here the sum like a B is the another matrix like a simpy dot matrix like 4 comma 3, right? So now if I want to find it like a rank, so how do I write? A dot rank, this one. So I have created two variables and now I have gotten rank 2. Similarly, if I write some conditions numbers like look here, so A dot condition number, yeah, connected components decomposition, but need to write here condition number. I have already imported conditions number something, yeah, it has been already inside of this. So we can define this problem simply by the creating the matrix object, and another is the conditions number, rank and mod. So this is the conditions numbers. We can create like a matrix as a conditions numbers. Similarly, if you want to write a normal norm of the matrix, so simply dot capital N, you can write here capital N like a norm, but need to write here norm as a look like this. Okay, so simply and norm. So let's see here. So I think, yeah, so it has been given this value look like this. And a dot norm, so if I want to get here a dot norm, a dot norm three root 6, right? So we can do the same things in a NumPy, SciencePy, using a NumPy arrays for a and b and the functions from the np dot l lin lg linalg and scipy lin linalg modules. So let's see, just if I write here like the another 2 and 3 and 5 and 4 and b I have already written. So we can do the same things NumPy and SciencePy using a NumPy array. So there is an alternative way. Let's see, just if I want to write here NumPy way, so np dot lin alg and dot matrix dot matr, here that dot matrix rank right here, and you can put here a. So you can get the same result like here rank you have gotten 2, and here you can np dot linalg dot matrix underscore rank a. So I think we need to get here, let's write again this variable, and then it is possible to, because np I have input it, don't worry. So let's see here. Now I'm going to do the np dot. I think np has not been the imported, so import and numpy as a np. So I think import numpy as np, numpy as np, right here. So you can write here np dot lin alg dot matrix underscore rank A. Okay, so I think I have gotten the sum problem, because same kind, so STB cannot be the SVT. Yeah, it may be the problem, don't worry. So don't need to the do here. Sometimes code has been updated, so don't worry. So same process we can apply, so don't worry, I have already discussed all these process. So the direct approach to solving the linear problem, and next time I will try to go with the new code. So the solving of the linear problem to the compute and the inverse of the matrices A and multiply it with the vector B. So this is not the most efficient computational method, but if I want to find like a solution vector X and better method like a LU factorizations and matrix A, and such as like A will equal to capital A will equal to capital L or U, lower triangular matrices, this type of key, and where L is the lower triangular matrices and U is the upper triangular matrix. So when L and U, the solutions vector X can be efficient constructed by the first solving, like if we write the another variable L small y will equal to B and forwarded the solutions, U X will equal to Y. You can say also the backward subtractions. So let's see, just L and U are triangular matrices, and these and if I try to, I have already written the two matrices, and now I am going to try here something like this is like one variable like L comma U comma underscore, and now this will equal to A dot L U decompositions, L U decomposition and parentheses. Okay, and now I want to print here L. See here, I am going to print here. Okay, so L has been printed, look like this 1 0 and 5 by 2 and 1 this way. Similarly, if I want to the print here U, so is it possible to print? Absolutely, this one is the U has been print like, because rectangular symbol has not, yeah, it is look like this. If L and U, you can lower and upper triangles has been become like a multiplication way. So if I write lower and upper triangle, yes, it is possible to the multiply. Yeah, you can get easily 2 3 5 4. Now if you want to write here some value like x will equal to capital A, so we write here x will equal to capital A dot solve. Solve and B, so look like see here and print x, and now print x. Yes, I have gotten look like a -1 by 2. So for the numerical problem we can use LA dot LU functions from NumPy linear algebra modules, and it returns a permutation matrix P and capital L and capital U matrices such as A will equal to PLU like SimP, and so we can solve the linear systems like AX will equal to B without explicit calculating like a L and U matrices. So let's see, just if I write here P is your first variable and L is your another variable and third variable is a U, and will equal to LA dot LU and put here A. LA dot LU and put here A. So now I want to look here what is the N. So let like a L represent look like this. What is the P and what is the U? So you can see also like a P and it has been printed, and it look like a U, so it has been printed. Okay, so P dot, if you write here dot plot, so P dot like a dot and U. So is it possible to like U, and you can represent here look like this. Another, if you want to like solve this A and B, so you write here LA dot solve and capital A comma B. So the advantage here, so I think this is not a working here. What happened? Let's see, just I am going to assume here M will equal to, and then right here the print here M. Is it possible? Let's try, don't worry. I think no, this is not a working LA method, so don't worry. So number of code has been changed, so don't worry, let's see. So dot is a working, so let's see. So the advantage of the using like a SimP is of course that we may obtain exact result, and we can also like include symbolic variable in the matrix. So, but we will see here, not all problems are solving a symbolically, or it may give a exceeding lengthy results. So the advantage of the using the numerical approach with a NumPy or SCIPy on the other hand is that we are guaranteed to obtain the result, although it will be an approximate solutions due to floating point of error. So this is a way we can easily represent this point. So I hope this video will be helpful for anyone, and next time I will try to solve like a singular and other the some specifications. Thank you.